today, the student will understand a cross-section of a rectangular prism and a rectangular pyramid, both of those things. All right, so you're like, what is a cross-section? Okay, so look at that first picture. It says a cross-section is like if I took a slice of it. So I have a couple of shapes for those of you guys who need to actually see the shapes. Okay, so this right here would be a rectangular prism. Okay, so imagine this is like a block of cheese. That would be a large block of cheese. And I took my knife and I sliced directly through the block of cheese. Okay, and so I sliced through it, bam. There's my slice. It would look like this. Okay, or I could slice through it this way, bam, and then it would look like this side. So that's what a cross section is. Okay, and it's a little hard to see. Some of you guys who are more spatial, it's going to seem a little bit easier. Okay, so there's the 3 different slices. So that's just like this container right here. I can slice it as a vertical slice, which is the first one. So slicing it right here. This is another type of vertical, so I could go this way, or I could go this way, right? Or I could do a horizontal slice. I always remember horizontal is like the horizon. You guys know what the horizon is?
No.
What's the horizon? It's like where the sun comes up, right? So the horizon's always like this. That's how I remember horizontal. So that's going to be a horizontal slice. Okay? All right, so what we need to be able to do is figure out what is that slice going to look like when I slice it. Okay, what are the sizes of that slice going to be? Okay, so if you look at the 3 shapes that are drawn here, this is the same one over and over again, all 3 of them, but they're different slices. So this one we have a vertical, horizontal, and another vertical. So look at these slices up top, and which one of those, so if I don't know if this one looks slightly more, I don't know if any of them look better. So if this one is here and I slice this direction, what are my side lengths going to be for that rectangle that I just formed? Here's the bottom of the box. And so imagine this is sitting here and we slice it this way. So what is the bottom slice going to be here? Cassidy?
The 10 centimeter, 8 centimeter one.
It's going to be the 10 centimeter going this way. Good. That's 10 inches across. And then what's this going to be? The 12 is going to go with that one. The 8 is going to go with that one. So you're going to get a 10 by 8? 10 by 8? Okay, do we have a 10 by 8? We do, right here. Alright. Okay, let's look at the next one. So this is if I slice it going this direction. So I'm slicing directly through like that. So what do you think? So the slice is right in here. It would be basically that shape. So what's that one going to be?
10 by 12.
A 10 by 12, good. This is the 12. This is the 10 on this side right here. You see how that would match up with that one? So that one would be a 10 by 12. Okay, now, we're going to assume the last one's a 12 by 8 because that's all that's left, but let's see if that makes sense. So this one is taking the slice and going directly through like this, right? So it's basically this right here. Okay, so what is our length here?
8.
Well, 8's right here, right? So it's going to be 12 and by, oh, sorry, you're right, Sam, by 8. How many of you see that easily? Not at all.
I don't know, where's the 10?
Okay, so the 10, okay, so imagine this is the box. The 10 is this distance right here. This bottom distance. Do you see if I hold it? I said I don't have one that matches it. But do you see how that goes right across the bottom? Okay, so that's the 10. The 8 is this part going up. And the 12 is this long part here. Yes, Kendall?
Why do we need to cut it in half in order for us to figure out that?
Because that's what the learning goal is to try to find its cross section. So when they cut it, that's called a cross section. And you're trying to find the dimensions of that cross section. Which would be the same thing as basically saying what is the dimension, like if I'm cutting it like this, it would be the same thing as saying what's the dimensions of this face. It would be the same thing. Yes?
When we're talking about dimensions, are we saying like dimensions?
Yes, what I'm saying is, see the rectangles that are at the top? Imagine that I could take a piece of paper and slide it in here and then pull it out. That's when I say dimensions, this is a 10 by 12 rectangle. That's its dimensions. Okay, anything else? Did I answer everyone's questions? Okay, all right. So let's try this one and see if you can figure out. Why don't you guys try this one on your own, and we'll see how much more I need to help with it. Okay, see if this helps a little bit. Okay, so do you see there's my 4, there's my 6, and there's my 5. That's what that picture is trying to tell you. Can you kind of see it? 4 this way, 6 this way, 5 tall. All right, so this is slicing going this direction through it. Okay, so basically what I'm wanting to know is what is the dimensions of this side. Does that make sense? Because it's a slice going. You guys ever create what is that, Fruit Ninja? Yeah, think of this like Fruit Ninja, like it's going shh. And there we want to know what's the area of that side. So what would be the dimensions basically of the top or the bottom, since that's the slice I'm taking? Look at my picture here. Cassie? It'd be a 6 by 4. You see, this side's 4, that side's 6. This bottom would be a 6 by 4. Did you get it now?
I got it right.
Did that make sense? Kendall?
Is it the same by 4 by 6?
You could say a 4 by 6. Yes. You just can't use the 5 because the 5 is how tall it is. And if I chop it this way, the 5 has nothing to do with it. It only is these 2. Okay, what's been the most helpful? Was this the most helpful?
Yeah.
So I can help next hour? And it helps to have it written on here? Okay, all right, good. Okay, so that would be a 4 by 6. All right, so now look at the next one. Okay, if you only had to tell me one dimension, what was the one dimension you could tell me on this one? This one's slicing sideways like that, cross through it. Kendall? Okay, now you can't tell me this one because you don't know that one without doing some math. So there's only one dimension you can really tell me on this one. Catherine? It's not 3. It's the 2. Okay, so let's see if I can make this one look similar. All right, so this one would be like this. This is going 2 this way. It's going 3 tall. And then this long side over here is 10. So this right here, see it slicing through here and going up like this. So do you see how it would then be along that 2 side? Because there's the slice, here's the 2. The 3 is how tall it is. So the slice doesn't have anything to do with the 3. Yes?
The 10 part, like, isn't that the same measure still? You're just cutting the top off?
This would be, no, because it's going at a diagonal, and a diagonal is never the same length as a side. So you would actually have to find that length, which you could do, but I haven't taught you how to do that yet.
I mean, like, the bottom part.
Okay, that's if I sliced it this way, it's slicing it diagonal. It's not slicing it this way. It's slicing it diagonal. Does that make sense? And going across is not the same as going diagonal. Diagonal is always going to be longer. Okay? Any other questions on that one? Does that make sense? So this helps too? Okay. All right. Next one, which I think switches to the other one. Okay, so this one is the this shape, which is called a rectangular prism. Okay, where it either has a rectangle or a square on the bottom, but then it's not a prism, pyramid. This is pyramid. Okay, and this cross section's a little different. Do you see how this one's different? Why is this one different? Cassie?
Well, there's different levels on it, so there's more things you can do.
Right, what if I cut it here? How big a shape do I get if I cut it here? A pretty small one, right? What if I cut it here? And what if I cut it down here?
It'd be the same.
It'd be the same as this one?
Well, no, just as, like, as a whole.
Wouldn't this one be the biggest?
Yeah.
And then you have a smaller one and you get smaller all the way up to the top. So they're all going to be different sizes. Were these different sizes when I cut them here? Remember, if this was a block of cheese and I cut it, won't they all be the same size? So very, very different. So that's what they're trying to show you in this picture, that if I slice it on the bottom, I get a large rectangle. If I slice it in the middle, I get a medium size, and if I slice it at the top, I get the smallest. They're all going to be different sizes. You're not going to necessarily know what those sizes are. Okay? All right, then if you do a vertical slice, okay, now, this one's a perfect square. I don't have a rectangular one, okay? But imagine you had a rectangle at the bottom. If I slice this direction, I would get a different size than if I sliced this direction, if this was a rectangle, okay? So that's what they're trying to show you here. So here, right here, if they slice it this way, see how they got a wider triangle? If they slice it this way, again, if this bottom was a rectangle, they got a more narrow one. If I had a square base, they'd be exactly the same. This one would be the same because it's a square. But imagine that this was sitting on top of, that won't help. Imagine this was on top of this. If you slice this way, it's big. If you slice this way, it would be skinny because it would be small. I wish I had another one of these. That would be helpful. All right, so let's take a look and see if we can do it. All right. So check out these different cross sections. Okay, is there one that is like easy that you just see? Yeah, the second one. Because what would that cross section be if I sliced this fruit going this way? What do I get? I get a small triangle if I slice it this way. Small square. Okay, and on this one, okay, you don't know what the measurements are. You don't know. But you know that this side is 3 and this side is 6. So if this is 3 and this is 6, this is a 3 by 6, this has to be smaller. So does it make sense that it might be a 1 by 2? Yeah, you're going to have to just think a little bit on these. You're not going to be able to know exactly. But you know it's not this and you know it's not this because you know this has to be a rectangle. Okay, so that's how it's going to be on the homework. You're going to have to be like, oh, you just have to use you have to think critically to figure out which one it is. Okay, now let's do the triangular slices. So now we're going from the top through here. So basically when you slice it, you get a triangle. Okay, so we got to figure out which one goes with which one. Tegan?
So the second one goes with the first box. No, second one goes with the third, right?
The second one, okay, so see, here's the 6 right here. That would be this side. And I'm slicing it this way, so that means the base of the triangle right here would be 6. So the base of this triangle would be 6. This side would be 6. If I slice it like this, I'm going to get the big one of 6. Okay? Then imagine that this side is only 3, and I slice it. Here's this side is 3. This is 3. So that means the base of that triangle is going to be skinny, and it's only going to be 3. Does that kind of make sense? Do you see it? Yeah. Okay. So try the next one and see if you can do that one. All right. So this one is this exact one right here, because what's the base of that one? A 4 by 4, right? Which is a square. So it is this shape right here. Okay. How tall did it say this pyramid is? 6. Okay. So your triangle, what they're asking is, what are the dimensions? And oops, not right on board with that. And what is the cross section? What is the shape? Okay. So what's your base going to be? 4. If I slice it like this, it's going to be 4 going across. Okay, so here's my shape. The base is 4. How tall did you just tell me it was? 6. What do you know then about this side and this side? They have to be, what? No, because the height is 6. What do you know? You don't have to give me a number. I'm just looking at what do you know about those two sides? They will be greater than 6, because the diagonal is always greater than the height. Are they going to be same, different? They're going to be the same size, okay? Because this is going to be 2, this is going to be 2. This side will be congruent with this side. Does that make sense? What type of triangle has 2 sides that are congruent? Isosceles. So if they might ask you for the name. That's isosceles. Remember I said that's the one that's got the double S's? That's how I remember it. SOS helps me remember that too. Are we writing this stuff down? I see some of it on your boards, some of it not on your computers. All right, last one we're going to look at Oh, actually, no,